Signal conditioning, the non-inverting amplifier. Well, let's talk a little bit about that one. If you look at this diagram that is here, showing a operational amplifier connected in such a way that you have the signal input on the non-inverting input, and you have the inverting input connected to the ground via the voltage divider of R1 and R2, where R2 is a feedback resistor connected to the output voltage. And this is the connection where you have the non-inverting amplifier. Now there are some notes here. The output voltage is taken across the potential divider circuit consisting of R1 and R2, where you can say that the voltage potential at the node X, here to say exact, between the two resistors. Then you have the output equation where you have that this voltage potential at the node X is equal to the ratio between the voltage divider, where you have R1 divided by the sum of R1 plus R2, and you have then you multiply it with the output voltage. And here you should think of the general voltage divider. Also, as is with all amplifiers, we can say that there is virtually no current between the input, that is the inverting and the non-inverting input, and that there is virtually no potential difference between the inputs, so that we can say that the voltage potential at node X is equal to the voltage potential at the input. So Vx equals Vin. And then for the general amplifier, you have a definition that says that the gain is equal to the output voltage divided by the input voltage. And here we can take the two equations where we can calculate V out and V in, and divide them with each other, and then we end up with an equation that says that the gain is equal to the sum of resistor R1 and R2 divided by R1, which we can take further and say then that we can say that 1 plus the ratio between R2 and R1 is equal to the gain. Now, if we take the special case of the non-inverting amplifier, which is also called voltage follower or a buffer, it is where we have shorted the feedback resistor R2, and the inverting input is not connected to the ground, like this. So the feedback resistor is shorted, and then would mean that the gain would be equal to 1. That is, if you look at this equation here, where you say 1 plus R2 divided by R1, and if R2 would be 0 or shorted, then you only have 1 left in the equation, so the gain would be 1. Now, what is good about this is that you have the input impedance that is very high, and you have the output impedance which is very low, and then what you gain from this is that the resistance in the following circuit is low, and is less likely to be loading that circuit with this one. So this is used to impedance match what comes before and what comes after in a circuit. So this is about the non-inverting amplifier, and you have now information about how to calculate the gain, and also about the special case of the voltage follower or the buffer.